22nd, that is August 2024. I've come back with a new table, and the purpose of bringing these tables is because I want us to have familiarity with tables and how to copy this work up to the graphs. Therefore, today I'm having a table where I will be having number of 10 ohm resistor in parallel. Number of ohms in resistor in parallel. Therefore, this one is going to take us to another space where we'll be having a denoted quantity. I think it is length in centimeters. Then we have 1 over R, that is in per ohms. The units. Then we have the inverse of 1, that is of A, and it is in per centimeters. Therefore, we'll be having, when we have 10 ohm, when we have 2 ohm, and when we have 3 ohms, when we have 4 ohm, when we have 5 ohm, and when we have 6 ohms. Therefore, for us to get this, then it means that now the first question, before we get to the question, we have the issue to do with quantity A, when we have the distance recorded as 70.0 centimeters, 56.0 centimeters, 44.0 centimeters. We have 39.0 centimeters. We have 33.0 centimeters. And we have the last part where we have 29.0 centimeters. Therefore, in this case, I would like to have a new working, because the first thing you are told is to fill and complete the table. That is the first thing that you have been told. Therefore, you should be asking yourself, if you are having one resistor, this one can only be on its own. Therefore, its effective resistance will be 10 ohms. And if I take my working, or if I take my working, it will be the inverse of 10, which will be 0.1. And now this one is 0.1. I can add 3 zeros to make it 4SF. Then the second thing is when I'm having 2 resistors and they are parallel. We know that the RT for the 2 will be the same as R1, R2 over R1 plus R2. And this translates to us that it is 100 divided by 20, which will give us 5. Now, the inverse of answer will be 0.2000 in that manner. From there, we go when we are having the three of them, where we usually say 1 over RT is equals to 1 over R1 plus 1 over R2 plus 1 over R3. We are talking of they are in parallel. Then this becomes, that is 1 out of 10, 1 divided by 10, plus 1 divided by 10, plus 1 divided by 10. I'll be getting 3 out of 10. And this one simply simplifies that 1 over RT is 3 out of 10. Therefore, my RT will be 10 out of 3, which is 10 divided by 3. You get 3.333. This gives 3.333. And if it is 3.33, now I pick my calculator, I put 3.333 inverse. And in this case, I'll arrive at 0.3000. When we are having 4 resistors, then I will say 1 over RT is equals to 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R4. Each resistor is of 10. Each resistor is of 10. And when it is of 10, then I'll say 1 out of 10 plus 1 out of 10 plus 1 out of 10 plus 1 out of 10. I'll simply get 2 out of 5. This translates to me that RT will be 5 divided by 2. Will be 5 divided by 2, which brings about 2.5 ohms. And therefore, because we are looking at the inverse of resistance, or else the effective resistance, then I'll say the inverse of 2.5 will be 0.4. I can add 3 zeros to make it to 4SF. And then now, when they are 5, it will be 1 out of 10 plus 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 the last one, 1 out of 10. I'll be getting a half. So when they are 5 resistors, then 1 over RT will be the same as a half. Then RT will be 2. So now I get the inverse of 2. The inverse of 2, which will be 0.5000. If we continue up to 6, we can see the sequence is just increasing by 0.1. Therefore, we can also try when we are having 6 resistors. Remember, these resistors are in parallel. Then 1 out of 10 plus 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 1 out of 10. And this one will give me that RT is 5 out of 3, which is equivalent to 1.667. The inverse of 1.667 will lead me to 0.6. Therefore, I fill this part with 0.6. I add my 3 zeros to make it 4SF. Remember this one, we need it to have 4SF because we have involved division. Therefore, the inverse now of quantity A, which is in per centimeter. Now the inverse of 70, arrive at 0.014289. The inverse of 56 becomes 0.0178. 0.0178.6. The next one is 44, which will give me 0.02273. The next one is 39, which will give me 0.02564. The one for 33 will be giving me 0.03030. Then the last one, which is 29, will be giving me 0.03449. Now that is just part of filling the table. It is part of filling the table. It is part of filling the table. Therefore, I expect you to fill it in a good manner so that you may understand everything that is coming to do with that graph. I think because of lighting, some are approaching me, but that is not part of our problems. We should focus on the main agenda. Therefore, the next question is part B. Plot a graph of 1 over A against 1 over R. This goes up to 5 marks. This goes up to 5 marks. It may be limited here, but the good thing is that everything is feasible. When everything is feasible, then we can work out things here. Therefore, I will pick my graph paper here, and have the first thing is that I do make this axis of A from what is given, we can see it is given in per centimeter. Therefore, we include our units per them in brackets. From here, we go to the x-axis, which is 1 over r. It is given the units of per ohms, like that. Then now, you need now to transfer what is inside, what is in the graph, that is the table, all the way to this graph. So the second thing, you choose a suitable scale. The scale for x-axis may not have problems because it's just simple. 01, 02, 03, 04, 05, 06. I may either decide to go by 01, 02, 03, 04, 05, 06, or I may use the other mechanism of trying to make it 1. I can make it 1 by multiplying by 10 raised to power negative 1. I may make it to be 10, 20, 30, 40, 50, 60 by multiplying by 10 raised to power negative 2. Therefore, if it is simple, you decide what to choose. For example, I'll decide or I'll choose to multiply it by 10 raised to power negative 2. So that I make it 10, 20, 30, 40, 50, 60. Now that one for x-axis, it will be sorted. But now when it comes to the y-axis, it is rating from 0.014 all the way to 0.034. I may choose a better way that it becomes 0. Or else that is, I can make the 0.1429 to be 14 by multiplying by 10 raised to power negative 3. Therefore, I move to this side and say everything here is multiplied by 10 raised to power negative 3. And therefore, I start looking which will be better, or else which scale will be better. My scale of 5, 10, 15, 20, 25, 30, 35, all the way to 40 will be very much okay. Therefore, now I need to transfer everything which is here to be in this part. Therefore, I will go by the first one, which is 10. From here, it is 10 times 10 raised to power negative 2 against 14. So from this scale, one small box is having or else it is representing 0.25. Therefore, for us to have 14, we'll have 4 divided by 0.25. This goes from 10, I need to have 16 boxes. So my 16 is here. And now this is against 10. So I'll put down this one and circle it. The next one is 2, 0.2, which now we have said times 10 raised to power negative 2 will become 20. This one will go all the way to against 17. In this case, I may choose to have 17.8, or I round this one off to be 18. Therefore, if I round it to be 18, from 15, we'll have a value of 3. Therefore, the 3 divided by the representation of one small box, which is 0.25, I expect to have 12 boxes, so that it represents 18. So now I have 18 against 20, which is 12 boxes. So this is already 10. So now this is 12. That is representing 18. So against 20, my point will be here, like that. That is now my point. We move to the next one, which is 0.3. To me, because of the times 10 raised to power negative 2, it is now at 30. Against 22.7. Against 22.7. I may choose to have 22 or 23 from rounding off. Therefore, if I pick 23, above 20, I'll have a value of 3. 3 divided by 0.25, we arrive at 12 small boxes. So that is here, and this is now 10 small boxes from 20. So I need them to be 12. So this one becomes my 23. From there, we move to the next one, which is 40 against 25. 40 against 25. This one I may choose to have 26 or 25. So if I pick it to be 25, then it will be 40 against 25. This one seems to be very much offside. Sorry for the interruption of these insects, but still stick to the point. Now we move on to the next one, which is 5. To me, it is 50 against 30. 50 against 30. I'd go straight to this point, 50 against 30. And then the last one is 60 against 34. So above 30, we have a value of 4. So 4 divided by 0.25, this gives us 16 small squares. 16 small squares. 16. So at this point, I'm at 15. So this one becomes the 16, which is now at 34. Then now, I'll choose the line of best fit, where we'll have the majority of the lines taking this course. Where we'll have the majority of the lines taking this course. Therefore, if I draw it like this, if I hold it like this, then I will only have 3. If it is like this, I'll still have 2. But now, because of the rules that are followed for the line of best fit, then I'll choose this point, this one, this and that. Remember I said the advantage of using a dot and a circle is that you can have a point being touched in a tangential manner. Still, that point is correctly drawn. Therefore, if it is like this now, then I can draw my point. Like that. That now becomes my graph. And the reason as to why I have drawn it in this manner is because I had already gone through the intention of the graph. Because the first question was asking from the graph, determine the slope, which is now m of the graph. This one will automatically guide you on the nature of the graph that you are going to draw. Therefore, I got it to be a straight line. Now we can calculate the gradient or the slope. Then from this one, do not, kindly note this, do not use points from, do not use the points from the table. Why? Most of the points have been variated. They have either been drawn to the next number or drawn to the previous number while being transferred to the graph. Therefore, it will be unhealthy for you to use these points from the table. For example, if you remember very well, the point which is 0.227, we said in the graph now it becomes 0.023, which now, according to our graph, it will be it will be 23 times 10 raised to power negative 3. Then now, we pick any 2 points from this graph. For example, I'll pick this point and have another one like this. So I have to indicate where I will be getting my points in this manner. I have to indicate where I'll be having these points. In that case, I have to specify that I picked my points from the graph and not just necessarily from the table. Therefore, this one now becomes change in y over change in x. And our x is being represented by 1 over r, and this one is 1 over a. Therefore, I can now pick these 2 points. The first one, it is, the first one, we can say it is point 37.5, 37.5 against the one for y, it will be 25. And then this one will be that is 7.5 against 12.5 against 12.5. Therefore, I'll transfer what you have seen there, that the change in y, slope will be given by the change in y over change in x. And in this case, it will be 25 minus 12.25 times, I insist, the moment you are having the first place of substituting the change in y, ensure you give it times 10 raised to power negative 3, or else how you have specified the quantities on the y-axis. And this will be over 37.5 minus 7.5 times 10 raised to power negative 2, like that. Then in this case, we'll have 12.5 times 10 raised to power negative 3 over 30 times 10 raised to power negative 2. It is very important to have this. Very, very important. Then now I'll have 12.5 times 10 raised to power negative 3 divided by 30 times 10 raised to power negative 2. And this will give me 3.75 times 10 raised to power negative 3. That is what my calculator is giving me. Then this is not the end. Remember, this one is awarded 3 marks. You can have substitution at half, correct substitution for x, another half. correct or evaluation plus the answer. This is another mark. Answer and units. Answer and units. Therefore, this one we are supposed to record 3.75 times 10 raised to power negative 3. The units on the y-axis are per centimeter, like that. And the ones on the x-axis, they are in per. So if you write that one correctly, then you'll have it well done. Anyway, you can ask yourself, 1 over a centimeter divided by 1 over ohm, what do you get? What do you get? This simply will take you to 1 over centimeter times ohm, which is like ohm per centimeter. So this value here can be written as 3.75 times 10 raised to power negative 3 ohm per centimeter, or 3.75 times 10 raised to power negative 3 ohm per centimeter. With units, they are part of you to acquire all the marks. They are part of you to acquire all the marks. Therefore, now the next question will be, given that 1 over a is equals to x over kr plus 1 over k, where k is equals to 100 centimeters. Then determine x. This one is like telling you we should match this equation 1 over a is equals to x over kr plus 1 over k to match the equation of a straight line, that is y is equals to mx plus c, where our c is the constant or the y-intercept, x is quantity on x-axis, our m is the slope stroke the gradient, then our y is the quantity on y-axis. This one must be made. The equation given in the question is 1 over a is equals to k over k, that is equals to x over kr plus 1 over k. This equation must be simplified to match this. And how will it match? If you look at our graph, the quantity on y-axis is 1 over a. Therefore, if we say 1 over a is equals now, the quantity on the x-axis will be 1 over r. Therefore, this part of x over r or x over kr can be simplified to have x over k on its own. And this one will be x over k times 1 over r plus 1 over k. Symbol, but you are the one to simplify things. Therefore, this one will match our equation, that is y is equals to mx plus c. This one will match with the c. The 1 over r, it is the quantity on x-axis, it is matching. And then this part now becomes our slope. It becomes our slope. Therefore, 1 over a becomes the quantity on the y-axis. Many students, once they get into this equation from a graph, they do forget about the issue to match with the equation of a straight line, that is y is equals to mx plus c. Y is equals to mx plus c. That is the equation of a straight line. If you look at our graph, straightforward, it has met all these things from the equation of a straight line. Why? It is having a constant 1 over k. And I think I should add what is the meaning of 1 over k. In this question, we had what is x? Therefore, for us to get x over k is equals to m. Already, we got m, which was the slope, as 3.75 times 10 raised to power negative 3 ohm per centimeter. Hiyo tulikuwa nayo. Therefore, you just need to substitute that x over k, which is 100, is equals to our slope of 3.75 times 10 raised to power negative 3 ohm per centimeter. Remember, this one is in centimeter. Therefore, our x becomes 3.75 times 10 raised to power negative 3 times 100. If you look at the units, it will be ohm per centimeter times centimeter. I think this one is on the lower side and this one is on the upper side. Therefore, this will cancel out. Therefore, I'll say 3.75 times 10 raised to power times 100, it gives me that x is equals to 0.375. And the units will be, this one cancels, so I'll have my final answer is to be 0.375 ohms. Before I finalize the lesson, because today I had a step-by-step question, maybe probably tomorrow we'll have a session that is cutting across. What does this value represent? What does this value represent? Because now, yesterday we had an equation that doesn't have the y-intercept. But today we can clearly see that we are having a certain constant, which is the y-intercept. And if I may look at this, I can decide to say from the graph, from the graph, what is k? If we do not have the one that we have been given k here. This one we had already been given k. But now we want to understand what is k from the graph given the equation that 1 over a is equals to x over kr plus 1 over k. I would go straight to the graph and say that this is my y-intercept. Remember these values of calculating, and when you are sensitized or when the question is very much specific, that it is from the graph. Then now, I'll say if 1 over k is giving me my y-intercept, I move to my graph and identify what does my k, or else what does my y-intercept stand for, and that becomes the point. So if I clearly read these points, I will see that these are already 10 boxes, 5 boxes, 10, 15, 16, 17. So I'll say 17 times 0.25 so it is 5 plus 4.25. This 5, so 1 over k is giving me 5 plus 0. That is 4.25. 5 plus 17 boxes, which are giving me 4.25. But don't forget, it is times 10 raised to power negative 3. This one. It is times 10 raised to power negative 3. Therefore, this becomes 1 over k is 9.25 times 10 raised to power negative 3. K will be 1 over 9.25 times 10 raised to power negative 3. And therefore, at this point, the units were per centimeter. So now here, because this one now has gone down, the inverse will be out. So we expect our K to be in the value of in centimeters. Therefore, 9.25 times 10 raised to power negative 3. Then I get the inverse of it, which is 108.10. So 108.10 centimeters. Remember, this one can be written to 2 decimal points, even though it is in centimeters. The reason being it is from calculation of either multiplication or division. So now, if you look at 108 versus 108 versus the K that we had been given that it is 100, you'll find that the accuracy of our graph is above 80%. The accuracy of our graph is over 80%. So it is like they mean that this y-intercept could have cut at exactly 10 raised to power negative 3, which could have given us 100. For now, have a blessed night and keep working extra hard. I'm very sure we have some few days to go, some few months to go, then you sit for your KCSE. This is part of paper 3 that is striking so many students, but with this, it may become just a porridge or just saliva that you just need to swallow. Be blessed. Thank you. Kijeshi Kimau or Johnston Kimau, KBHS.